We're going to start day 4 notes by going over this example at the end of day 3. So we are given that AB is equal to CD. Notice that it's also marked over there in the diagram. So this is our given statement. And we're just going to follow along with what it says. AC is equal to AB plus BC. If you trace both of those, it's the two smaller segments adding together to give you the larger. So this is what we call segment addition. BD is equal to BC plus CD. It's the same thing. The two smaller segments add together to give us the larger. Now you'll notice here AB plus BC is equal to CD plus BC. We have this highlighted in red to emphasize that we are adding the same thing to both sides. And whenever we add the same thing to both sides, this is our addition property of equality. And if we play a little bit of matching game here, this AB plus BC we have seen before appear in step 2, and that is equal to AC. So what we're doing is we are swapping them out for one another. Same thing, CD plus BC is in this line up here above. And because it is equal to BD, we can swap it out. And when we swap these things out, in this case, it could be the transitive property of equality or it could be substitution, either one. So transitive property of equality or substitution would also be okay. All right, so on to day 4. Our right angles congruence theorem simply tells us that all right angles are congruent. Okay, our congruent supplements theorem and congruent complements theorem will have the same wording. Obviously, one is for supplements and one is for complements. But it's going to be a little confusing here at first, and I'll try to make that a little bit easier to understand as we work through some of these problems. What our congruent supplements theorem tells us is that if two angles are supplementary to the same angle, if two angles are supplementary to the same angle, or two congruent angles, then the angles are congruent. And I'll try to draw this out in a little diagram down below. So the same thing can be said about our congruent complements theorem. If two angles are complementary, to the same angle, or two congruent angles, then the angles are congruent. And our linear pair postulate simply tells us that linear pair angles are supplementary. Okay, so let's draw out some examples down here at the bottom of our congruent supplements theorem and our linear pair postulate. Let's start out with our linear pair postulate. So if I have a set of angles here, maybe they are angles 1 and 2. Let's talk about our statements and reasons. Okay, option number one for correctly using our linear pair postulate is to say that angle 1 is supplementary to angle 2, and then we put linear pair postulate. You can just put P-O-S-T is fine. Okay. Option number two of the way that you could use your linear pair postulate is in the event that we want to work these through addition, subtraction, multiplication, division, if we want to math these numbers. So if we want to math these numbers, I want to write them in an equation. So we could say the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees, which is another way that we can use that linear pair postulate. Okay, so now let's talk about our congruent supplements theorem. So I'm going to draw some angles out here. Let's say we've got angle 1 and we've got angle 2. And maybe we've got angle 4 here. And maybe we've got angle 3 down here. So here is our congruent supplements theorem. One thing that we could say is that if we know angle 1 is supplementary to angle 2, okay, maybe that's given. And maybe we know that angle 3 is also supplementary to angle 2 because that is given. Then think about this mathematically. If 1 is supplementary to 2 and 3 is supplementary to 2, then I can automatically say that angle 1 is congruent to angle 3 by our congruent supplements theorem. I could also say the same thing if I want to bring in angle number 4. So maybe we have angle 2 is congruent to angle 4, and that's given. And we have that angle 1 is supplementary to angle 2, and that's given. Then we could say not only that, let's see, we also have angle 3 supplementary to angle 4. If 2 and 4 are the same thing, and 1 is supplementary to 2, and 3 is supplementary to 4, then we could say that angle 1 is congruent to angle 3 by that congruent supplements theorem. Now, we're going to get a lot of practice with these. I know that it's a little bit confusing, but think about it mathematically in your head, okay? If these have a measure of 50, and I know that this one's 130, if I know that these two are supplementary, and I also know that these two are supplementary, then this has got to be 50, okay? So think about it in terms of numbers if you need to. You can work this out with math. It just tends to be a little bit more difficult and take more steps if you decide to work it with the addition and subtraction. So we're going to start here, and we're going to try to prove the congruent complements theorem. So if angle 1 and angle 2 are complements, I also know that angle ABC is a right angle, and I want to prove that angle 1 is congruent to angle 3. So let's see, if I've got my given statements, so angle 1 is complementary to angle 2, that is given, and angle ABC is a right angle, that is also given. I want to try to prove 1 and 3 are congruent to each other. Well, if I look at angles 1 and 2 that are complementary, that means they add to 90 degrees. And if I look at angles 2 and 3, I know that that is a right angle. So I can then compare angle 2, and if I take angle 2 away from both of them, then 1 and 3 are going to be the same. So let's go ahead and work this with the math, and then we'll talk about it in the shorter term. So I want to change both of these so that we have some equal signs. So instead of saying 1 and 2 are complements, let's say the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And we can do that because we know our definition of complementary. Complementary angles add to give us 90 degrees. Okay, ABC is a right angle. So let's change that one too. The measure of angle ABC is equal to 90 degrees because it is a right angle. Definition of a right angle. All right, let's see. Let's take this measure of ABC and expand that out because I need to bring in angle 2 and angle 3. So if the measure of angle ABC is combined of 2 and 3, then let's write that out. So the measure of angle ABC is equal to the measure of angle 2 plus the measure of angle 3, and that is just angle addition. Just like we did segment addition earlier, two angles combined to give me the larger through angle addition. And now we're just going to do some substitution. So if I know that ABC is 90 degrees, that means I can swap these two out for each other. So 90 degrees is equal to the measure of angle 2 plus the measure of angle 3. We're just going to substitute that out. And now I'm going to highlight here, if I have this is equal to 90 and this is equal to 90, then I can set those two equal to one another. So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. You could say transitive or substitution. And this is where we're going to use our reflexive property. I'm going to say, hey, the angle 2 in this one is the same as the angle 2 in the other one. So the measure of angle 2 is equal to itself. That is our reflexive property of equality. And now, if those two are the same, I can subtract them away. So the measure of angle 1 is equal to the measure of angle 3 because I subtracted angle 2 out of it. And now I just need to change the way it looks. So if 1 is equal to 3, then I also know that angle 1 is congruent to angle 3 because of our definition of congruent angles. Now, that is a whole lot, right? My goal is for you not to have to do all of that extra stuff. And up here, I'm going to show you how I would work this. Okay, so I'm going to change my color here. We're going to start out with the same thing. 1 and 2 are complements, and angle ABC is right. So angle 1 is complementary to angle 2, and angle ABC is a right angle, and that is given. Now, instead of changing our things to math them out, let's work on this a little bit. So we can go from here and say that the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle ABC. That is our angle addition. And instead of keeping going with the math, now let's say angle 2 is complementary to angle 3, our definition of complementary angles. And here are my two statements that I need. If 1 is complementary to 2 and 2 is complementary to 3, then I can bypass all that other stuff that we just did and say that angle 1 is congruent to angle 3 because they are both complementary to the same angle. So this is our congruent complements theorem. And here we have 1, 2, 3, 4 steps rather than all of these over here on the left. Are both of them correct? Yes. Is one shorter? Obviously. So learning how to use our congruent complements and our congruent supplements will really help. We're going to do the same thing on this one. So angle 1 is congruent to angle 4. I'm going to go ahead and mark those out, 1 and 4. And angle 3 is congruent to angle 5. I'm going to go ahead and write these in. Angle 1 congruent to angle 4 and angle 3 congruent to angle 5. That is given. And I want to know that 2 is supplementary to 4. Okay, so think about these bridges that we can make. I need to bring angle 2 in somehow. And the way that we can bring angle 2 in legally is either by way of vertical angles or by the way of a linear pair. So either one will work. But I've got to bring in this word supplementary somewhere. Okay, so let's start out with what we know with angles that we already have. Let's list maybe, let's see, 2 and 1 as supplementary. Angle 2 is supplementary to angle 1 because they form a linear pair. So our linear pair postulate. And what do we know about 3 and 4? They are also supplementary for the same reason. And then what bridge can I bring in here? So let's see. I know that 3 is congruent to 5. And I know that 2 is also congruent to 5 because they are vertical angles. So if I want to start up here at the top, I can go ahead and put that in. Angle 2 congruent to angle 5 because they are vertical angles and vertical angles are congruent. And then the only other thing that I need is to say that 2 and 4 are supplementary. Angle 2 is supplementary to angle 4 because of my congruent supplements theorem. Now, there are lots of different ways that you can do this. You could use 1 and 2. You could use 1 and 5. There are lots of different ways to work this, but the key is just to make that bridge using either vertical angles or our linear pair. All right, so we are given that C is the midpoint of BD and B is the midpoint of AC. So C is the midpoint of BD, and B is the midpoint of AC. So I'm going to go ahead and mark this. Let's see. C is the midpoint of BD, and B is the midpoint of AC. So what you'll notice is I have all three of these marked the same. Now, I need to list those markings down here in my proof. So because C is the midpoint, that allowed me to say that BC is congruent to CD and that AB is congruent to BC. All of that because of what is stated up here, our definition of midpoint. So we both have two things in common here, BC and BC. And if both of those are congruent to BC, then they are congruent to each other as well. AB is congruent to CD, and that is our transitive property of congruence. If 1 is congruent to 2 and 2 is congruent to 3, then 1 is congruent to 3 as well. And then let's take a look at these angles and we'll be done for today. What can you conclude? Remember, we can only conclude vertical angles and linear pair. So we could conclude that this angle over here is 125 and that we have 55 and 55. We could take this one and take it a little bit further. So we have 90 and this one here is also 90. And if AOE is a straight angle, then we have 90 over here as well. And all of these would end up being 45 degrees. And then if we take a look over here, this is a great example of our congruent supplements theorem. So I'm going to write it out as if it were a proof. I'm going to number these angles 1, 2, 3, and 4. Okay, so we are given that angle 1 is congruent to angle 3. And now we can look at vertical angles or linear pair. So I could say that angle 1 is supplementary to angle 2 because of our linear pair postulate. And I could do the same thing with 3 and 4. Angle 3 is supplementary to angle 4. And if 1 and 3 are the same, and 2 is supplementary to 1 and 4 is supplementary to 3, then I know that angle 2 is congruent to angle 4. And that is that congruent supplements theorem. Now, as I said earlier, there are going to be multiple ways to use that congruent supplements theorem, and we will get lots of practice with it. So I actually think that this proof up here is one of the more confusing ones to try to use congruent supplements for, so I'll try to track down a couple of others that are a little bit better examples. This one down here is an excellent example of a way to use that congruent supplements theorem.